Curvature. What is a curvature? Curvature is a quantitative expression of a surface outline, and it can be dipped and curved, concave and convex, as you might see on this image. Dam and curvature. The curvature function displays the shape or curvature of the slope. A part of a surface can be concave or convex. You can tell that by looking at the curvature value. The curvature is calculated by computing the second derivative of the surface. So on these two pictures you can see digital elevation model on the left side and the curvature function surface on the right side, and curvature is derived from digital elevation model. And minus values and plus values as well as zero values indicates the certain surface of the curvature of a surface. Influence and applications. The output of the curvature function can be used to describe the physical characteristics of a drainage basin in an effort to understand erosion and runoff processes. The curvature value can be used to find soil erosion patterns as well as the distribution of water on land. The profile curvature affects the acceleration and deceleration of flow and therefore influences erosion and deposition. The planform curvature influences convergence and divergence of flow. So on this image you can see that each pixel has a certain value which represents a certain level of altitude. So these pixels have low altitudes and low values. Meanwhile, these pixels have higher values, and these areas therefore have higher elevation. In this case, curvature in this case are convex, and water just pulled down by gravity from higher altitudes to low altitudes, and these areas are prone to erosion. Profile curvature. The profile curvature is parallel to the slope and indicates the direction of maximum slope. It affects the acceleration and deceleration of flow across the surface. A negative value indicates that the surface is upwardly convex at the cell and flow will be decelerated. So on this image you can see that if the curvature has minus values, the surface is convex upwardly, and in this case if water falls into this area, the speed of water is decelerated, and therefore such kind of curvature is less prone to soil water erosion. Meanwhile, a positive profile B indicates that the curvature is upwardly concave. So concave curvature and at the cell, and the flow will be accelerated. So if water precipitation falls to this area or even this area, the gravity force moves down water stream on a fast velocity, and this kind of curvature is very prone to severe type of erosion. A value of 0 indicates the surface is linear. So if the value is 0, it's linear. This kind of curvature is less prone to soil erosion compared to this. More prone to soil erosion, so comparing to minus values, but less prone to comparing to plus values. Planform curvature. The planform curvature, commonly called plan curvature, is perpendicular to the direction of the maximum slope. Planform curvature relates to the convergence and divergence of flow across the surface. A positive value A indicates the surface is laterally convex at the cell. A negative plan B indicates that the surface is laterally concave at the cell. A value of 0 indicates the surface is linear. Standard curvature. The standard curvature combines both the profile and planform curvatures. The profile curvature affects the acceleration and deceleration of flow and therefore influence erosion and deposition. The plan curvature influences convergence and divergence of flow. Considering both plan and profile curvature together allows you to understand more accurately the flow across a surface. In the following diagram, the columns show the platform curves and the rows show the profile curve. The platform columns are positive, negative, and 0, going from left to right. The profile curves are negative, positive, and 0, going from top to bottom. Curvature in ArcGIS. The curvature tool is to calculate the second derivative value of the input surface on a cell-by-cell basis. For each cell, a fourth order polynomial of the formula is fit to a surface composed of a 3x3 window. As you can see on this image, it's a polynomial equation of a second derivative, but do not worry, ArcGIS computes it on its own. So the coefficients A, B, C, and so on are calculated from this surface. The relationships among the coefficients and the 9 values of elevation for every cell were numbered. The output of the curvature tool is the second derivative of the surface. For example, the inclination of slope is minus 2 multiplied d plus AE multiplied to 100. So there are two types of curvature functions. One is in 3D analysis tool in raster surface curvature, and the second one is in spatial analysis tool. And so this is the end. Hey guys, if you liked the video, please consider supporting the channel by purchasing online courses via my Udemy's profile, GIS Lab. Here you can find multiple courses regarding GIS remote sensing. The link to the profile is below.